Welcome again, everybody. My name is Craig Broccoli. I'm the Associate Director of Admissions for Binghamton University. I'm actually based in New York City for Binghamton. And today we're going to be talking about the Watson School of Engineering, which is super fitting for me. I actually studied as a student within the Watson School of Engineering. Mechanical engineering is my major, and I stayed on for an accelerated grad degree in business. So I love talking about this subject matter. But joining me today, we have a whole suite of guests, both from the admissions and the engineering school. So I'll let you go ahead, Doug, and introduce yourself.
Hi, everyone. My name is Doug Harrington. I am another admissions counselor here for Binghamton University. I am specifically the Watson liaison for the admissions office. So I do work directly with the Watson School for both engineering and computer science. So I'm going to be hanging out here and helping with this presentation, mainly in the Q&A section portion of the webinar here. I am also a Binghamton alum. I did graduate in 16 and 17 respectively from our School of Management here.
Great, and from the Watson side, we have one of our professors here, so go right ahead, Kuhn.
Hello, my name is Kuhn Gieskes. I am the Assistant Director of the First Year Engineering Program. I'll talk more about what we are in a little bit.
And some of our students will go down the line. Daniel?
Hi, my name is Dane Kabachi. I am a sophomore computer engineering student and one of our peer advisors here on campus.
Abby?
Hi, I'm Abby Johnstone. I'm a freshman studying industrial and systems engineering.
And Jessica?
Hi, everyone. I'm a senior in biomedical engineering with a concentration in devices and instrumentation.
And we have Maya.
Hi, I'm Maya. I'm a junior majoring in industrial and systems engineering.
And then Dominic.
Hi everyone, I'm Dominic. I'm a junior studying mechanical engineering.
And Shannon.
Hey everyone, I'm Shannon. I'm also a junior studying mechanical engineering, and I'm also doing a minor in sustainability.
Awesome. Joel.
Good afternoon, everyone. I'm Joel. I'm a sophomore studying electrical engineering.
Hassan.
Hello, everyone. My name is Hassan. I am a third-year mechanical engineering student.
And finally, Amelia.
Hi there. My name is Amelia. I'm a junior studying biomedical engineering, and I'm also the assistant training supervisor for the tour guide program. So I work for admissions as well.
Great. And we have plenty of representatives here. We have a lot of opportunities for you all to ask us some questions in the Q&A section. We're going to cover a lot of content as quickly as we can. We're going to have a chat hour right after this, so you can actually live chat with us face-to-face for any of those other questions. Throw any of your questions in the Q&A box, but as we go through this, you'll see that we'll probably touch on a lot of that, so we'll have some live session at the end of this to answer some of those questions. I'm going to share screen right now and talk a little bit about Binghamton, and specifically where Watson School of Engineering fits into our undergraduate studies at Binghamton. So hopefully you all can see my screen right now. We're going to go ahead and at least make sure that when you come to Binghamton, congratulations on all of your acceptances yet again. Binghamton University is a comprehensive research university, and we're located about 3 hours upstate in New York. And when you look at what we are as an institution, I just want to shed some light. There's 6 academic colleges. The Watson School of Engineering is one of them. And as an R1 research university, we do research across the board. And that's a big component of what makes Binghamton a strength these days, not just in the Northeast, but nationwide and frankly, worldwide. The ability to get your bachelor's degree all the way up through your PhD, with the 130 or so areas of study. Even our engineering students go well beyond just engineering as an area of focus. And the liberal arts core, that's probably one of the biggest value pieces of the Binghamton degree. Even for our engineers, when you go out there into the quote unquote real world, you have that liberal arts background to stay flexible, to stay adaptable, to put into action all the stuff that you do know now about your math and your science and the engineering disciplines. And with 14,000 students, undergrads coming in from all over the world, it's an incredibly diverse team of other students you're working with, often at your academic level and maybe even beyond. And that's the magic of coming to Binghamton at a residential setting where you could really connect with students in many different capacities within your major and well beyond that. Now, over the years, the Binghamton area has been a hotbed for innovation. IBM started here a long time ago. Flight simulation was invented in the area. And the engineering school specifically has taken on a big level of challenge of being that next generation of innovation that comes out of the Binghamton area. And part of that is what Binghamton University is here to provide, where there's over $200 million worth of new facilities that have opened up over the last 10 years or so within our Watson School of Engineering, and the sciences added into that, which means there's a lot of faith in the Binghamton community in solving some of the world's bigger problems. And that's what we do as engineers, right? We're here to understand where the problems are, who's dealing with those problems, and also coming up with the solutions to those problems. Now, there's a lot added into that engineering community and amenities that we offer our students, and we'll touch on some of that. I'll let our students talk about the learning communities such as core and engineering learning community. But we bring in faculty as well that are here to work with our undergrads. These are leading experts in their field. We have people like Dr. Stanley Whittingham, who's technically a chemistry professor. He just won the Nobel Prize after inventing the lithium-ion battery. And he does a lot of his research overlapping with our engineering disciplines, part of the big reason why we're able to bring in these centers. We have the Northeast Center for Chemical Storage, for Energy Storage, Center for Autonomous Power, for solar power. We have many different opportunities for our students to not just get an undergrad degree, but go on and get a master's or even a PhD, some of those in accelerated fashion. We just opened up a brand new center for smart energy that's added in addition to our innovative technologies complex, which joins in with our newest engineering school. There's plenty of high-end state-of-the-art research labs that you'll be working with as a student for sure. That's part of the experience here, where you get to merge the theory, the sciences, and the math side into what would be the hands-on components. I will stress though, I mean, this is what I remember clear as day as a student here. There's an incredibly collaborative environment here. We bring in a lot of really bright students like yourselves, but you're going to be working together with those bright students day and night. And that's the idea here of working at a residential college, where you spend a lot of time together as students solving some of these bigger problems. And that's a huge aspect and part of the value of the Binghamton degree. And I want to share a little video that goes a little above and beyond what your typical day in the life here at Binghamton would be. And that's going to be more or less what you can do even as a student, which might even stretch beyond just engineering specifically.
Each learning community at Binghamton University has an overarching theme. In Mountain View, we selected STEAM, which is a concept that has gotten a lot of attention nationally, first in the K through 12 environment, but more and more it's being broadened to libraries and universities. The idea is taking the STEM fields, science, technology, engineering, and math, and infusing them with the arts. Thus, the arts becomes an integral part of STEAM. Why STEAM? I think a good illustration is the cell phone. If we had relied solely on technology, then this probably wouldn't be as pretty and as small and as useful, and the user interface would not be as easy to use as it is. So one of the things that we're doing is creating a STEAM room, a place where students can go and experiment with technology, with the arts, with crafts. So learning will occur in the classroom, but it will also prepare them for the workforce.
The STEAM room is a place that all students, no matter what background, whether it be like a technical background or artistic background, can come into one place and create together. I would say the STEAM community kind of found me. I am a student of the Watson School of Engineering. I've been so ever since I got to college, and I've also been an artist for all my life. I use the STEAM room for as many things as I can think of. Whatever comes to mind, I go down there and try to hash it out, try to bring it out. So I'll use the drawing section to kind of sketch out my ideas, and then if I really want to make this thing and see it, I'll go to the computer design area, the CAD programs, and see if I can really see this object and see it in the 3D space. And if not that, then I'll just tinker around with the Arduino projects, or even try to produce a song or two. My goal in life is to prove to people that like you need art to make engineering work, that like all designs that exist are beautiful designs, and because they're beautiful, they're efficient.
And I see a lot of you are jumping in and asking a lot of questions. Our team is trying to write them back to you, but we'll have some time towards the end to do some live question answering at least. And so certainly you might want to hold on to some of those questions for the end. That way we could address them live. At this point though, I'm going to stop sharing my screen and I'm going to let my colleague join in and talk a little bit about that first year program, what it means to come to Binghamton.
Good afternoon. Again, my name is Kun Gieskas. I am the assistant director of our first year engineering program, and I'm going to talk a little bit about who we are, what we do, and what you would do here as a first year engineer. As students get to the university, why are we not? As students get to the university, they are not mechanical engineers, electrical engineers. They are just engineers, and all engineering students share the same first year program. Our name is the Engineering Design Division. We have faculty, obviously, from director and down to adjuncts, but more importantly, we have graduate teaching assistants and undergraduate course assistants. These are students that represent all the majors. We specifically get graduate teaching assistants from all the different disciplines, and also our undergraduate course assistants. We make sure that we have representatives from everyone. This is to help students sort of choose where they want to go and to make those decisions that all first year engineering students have to make. For us, it's been a long time since we've been in the shoes of a first year engineering student. So we feel it's really important to have those available that are closer to their age and closer to the decisions that you've made, they made maybe a year or two beforehand. Now, our engineering design division, our engineering courses in the first semester and in the second semester follow the same kind of a shape. There's a lecture that has the majority of students, and then two-hour individual classes where it's about 24 students in each. The lectures are led by Dr. Elmore and myself, but we also have a lot of guest lecturers come in from the departments, from local industry, from advising. And this allows us to teach not only our main concepts of engineering design or engineering analysis, but also to discuss the disciplines. We have our department representatives come in to do that because if I'm a mechanical engineer by background. If I'm talking about mechanical engineering, obviously there's going to be some passion there. But if I'm talking about biomedical engineering, I didn't go through the program. I don't live it day to day. And so that's why we have the biomedical engineering department come in to talk about that. That way you get that passion, you get the day-to-day knowledge about it. Our lab sessions are cover our basic tools that the engineers use in their projects. Computer-aided design, circuits, simulation software, and programming are the main topics, and then many more are cycled in. And our communications classes, our 2-hour discussion sessions every week, cover team management, presentations, reports, research, but all of them are run through project-based learning. Students also take math, science, and gen ed courses each of these semesters, so it's not just these couple classes. But like I said, we do project-based learning. We think it's the best way to teach anything, get your hands on stuff, actually do the work, and it helps a lot. So in our fall semester, we start with a very quick project. It's only 6 weeks long, but it's a reverse engineering project. The student teams end up getting a cheap appliance. They have to take it apart, figure it out how it works, figure out all the parts, measure them, see how they all fit together, create CAD models, and then present on how that toaster or shaved ice maker or thermometer actually works. These pictures are all student projects. They were all created within those 6 weeks. And somehow I ended up picking only red themed projects. The second half of our fall semester is an Arduino project. Arduino is a programmable microcontroller. It's a really nice little platform. It's cheap and easy to use. But we give our student teams, those same teams that worked on the first project, they now get a very basic, let's say, rock, paper, scissors project that really just has 3 buttons and a little screen. They are then tasked to make it their own. And so that top picture there, they actually took the rock, paper, scissors and turned it into a Rock'em Sock'em Robots game with the inputs being, if you win, they punch each other. But each team really makes it their own, and then we present them all at an expo at the end of the semester, which is just a huge event. Everybody's celebrating, everybody's done with the semester, and it's a lot of fun. In our spring semester, we have one big project, and that's a conceptual design project. We aim these projects to be either assistive devices or sustainability-driven projects. The examples on the board or on the screen here are a dosimeter for the blind so that they know how long they've been out in the sun, a controller for somebody, I believe that project was for somebody that only had the use of their legs, and then a sustainable design for a TV that limits power usage throughout the day. So these are all student-created, student-driven projects, and they're a lot of fun, but they span the entire spring semester. As I said, when students join our first-year program, they are just engineering students. At the end of the first semester, we ask that they choose or indicate what engineering major they're aiming to go into. They can still change their mind throughout the first year, but at the end of the first semester, we ask for a tally to see where people are looking to go. Now, there's 3 types of students that come into the program. Those that are completely undecided, they have no idea what engineering field to go into. Those that think they know what they want to go into, and those that absolutely know what they want to go into. But at the end of being introduced to the other majors, they all change around. As you can see from these charts, there is that about 10% undecided group that ends up picking a major. But from the other departments, they all change their minds. Things change throughout the semester. And I believe one of our students that's with us today has made this change a couple times. We also have some minors, sustainability engineering minor, a general engineering minor, and then some others that are not within the engineering design division. The general engineering minor is just for non-Watson students who still want to sort of dabble in engineering, that's how we like to put it. But the sustainability minor is a very popular one within the engineering field. I mean, obviously right now everything is geared towards sustainability. We want to stay on this planet a little longer, so it's lovely. Lastly, we have lots of organizations and clubs for students to join. These they are in all flavors, and whatever you want to go into, there is likely a club on campus that will help you meet that goal. All right, so now we will turn it over to the students who will talk about some of their majors. Thank you.
Both of us are former students, so we love to talk about the stuff maybe we got to do, but I think it's great to hear from our current students. So let's go major specific. Let's start with biomedical engineering.
All right, so hi everybody. Hi again, I'm Jessica. Like I said, I'm a senior biomedical engineering student here. One of the great things about BME is that there's 4 different tracks you can pick, which really makes Binghamton unique. You can do the biomedical devices track that I'm in, computational biosystems, pre-health, so that's where all the pre-med students go, and then biomaterials as well.
All right, and then alphabetically, I'll say let's go with computer engineering next.
Hi everyone, it's Dean again. So computer engineering is very similar with electrical engineering. So Joel talked more about the electrical side, but we focus a lot on robotics and robotic system applications, and we have a lot of projects within our department that actually offer that. So I actually run our rover team here on campus as well as the combat robotics lead. So we build tiny fighting robots as well as a large rover project, and work a lot on the electronic portions of that to really make sure that we're highly successful. And I also am on our sustainability minor, so love that as well.
I'm studying electrical engineering. I'm a sophomore. And the unique thing about Binghamton's electrical engineering and computer engineering program, like Danny was saying, we have this flipped classroom approach. So what it pretty much is we watch lectures at home or like in our dorms. They're usually like half an hour to an hour long, and then we come into class and actually apply that knowledge. So we take it not just to the theoretical level, but also we get to apply what we've learned and really do projects reinforcing that. And those projects, not only do they teach us a lot of things, but they let us like kind of beef up our resume, which is what helped both Danny and I get internships after our freshman year. So after my freshman year, I'm sure Jess will get into this later. She worked at Regeneron just like me, which is a pharma company you guys might have heard about. It's in the news a lot because they're doing like coronavirus vaccines and stuff like that. So I'd be happy to talk about that later.
Great, now we got ISE. We'll have two people speak about that. Maya, why don't you take us first with your take on ISE, then Jackson can follow up.
Yeah, all right, so hi again, I'm Maya. I'm a junior industrial systems engineering major. So I've definitely noticed like most students don't know what ISE is before they come to Binghamton. So very simply put, people refer to it as the business engineering, but really at the root of it, it's taking any system or any process in any industry and trying to make it better using statistics and calculus software and modeling techniques. And it's just very unique in that you can apply it to any industry and really get creative with your degree. So last summer I interned at Raytheon in Space and Airborne Systems, which is a defense company, but a lot of people will also go into healthcare, which like with everything that's happening now, trying to expand the capacity and the effectiveness of those is really important.
I'm Jackson. I wasn't here before because I was having some trouble joining the meeting. I am in my third year. I'm an industrial and systems engineering major. I came into school as a biomedical engineering major, then changed to mechanical engineering, and then changed to industrial and systems engineering. So if you have questions about changing your major or anything like that, I'm the person to talk to. And as far as internships, this summer I'm going to be working at Vines, which is a local community garden organization, and I'm going to be working as the urban farm share assistant.
Great, and now mechanical engineering.
All right, so the great thing about mechanical engineering is how incredibly versatile it is. As far as your coursework goes, you'd be focusing a lot on your calculus, your physics. We also do a lot of coding in MATLAB and computer-aided drawing on both Solid Edge and Creo. So we really get into a little bit of everything. We do a lot of projects as well. Last semester, we ended up, for one of our classes, actually kind of designing an airplane landing gear, which is something that was really cool to work on. And then as far as prospective jobs, again, it's so versatile. You can honestly go into so many different things. My internship for the past year has been working within HVAC, so that's heating, ventilation, and air conditioning. You can go into anything about like automotive, which Dominic might want to talk about more a little bit later. So yeah, it's really great.
Yeah, the versatility between all these different degrees, we try to make sure you have that capability to dive deep within your major, but stay broad as an engineer and how you can apply these different mindsets I know you all have. And even with Jackson, your storyline of switching your ideas quite a bit, that's great. You can do that at Binghamton. Before we get into some more of our live questions, I want you to address some of these things, students. I'm going to play a quick video. So I'm going to share my screen again. This is coming from the Dean of the School of Engineering. Just giving you a little overview, his take on it.
Congratulations. I'm Hari Srihari, Dean of the Thomas J. Watson School of Engineering and Applied Sciences. These are unusual circumstances. I'm unable to meet with you in person. I'm delighted to be able to speak with you virtually. I'm proud and humbled to be part of an organization that continues to make groundbreaking discoveries that propel the world forward. And our work in building the Watson School into a world-class institution has not gone unnoticed. The achievements of our faculty, students, staff, and our alumni are receiving more recognition. For example, we are consistently ranked among the top engineering schools in the world. We dedicated a state-of-the-art engineering and science building as part of the Innovative Technologies Complex. And we are renovating our existing engineering building to meet the challenges of the 21st century. A Watson education focuses on finding solutions to real-world problems through hands-on, team-based projects. Taking part in these projects will give you a competitive edge in graduate school or in the job market. I hope you will choose to become part of Watson's legacy. Congratulations again.
Give an opportunity for our current students to go into a little bit more depth about what they're doing now at Binghamton. I know some of you shared some facts and fun storylines there and some of the research and internships that you lead into. But first, I would like, just out of curiosity, if anybody wants to talk about a project they've worked on, even as an underclassman or as any of our seniors with your senior design project, would anybody like to share one of the projects they're working on?
I can jump in here. No one else has anything. So like I mentioned before about our Mars rover project here, the Mars rover team is a competitive team of about 25 students from every discipline within Watson. So we accept all 5 of our core engineering majors, our CS majors, as well as we have nursing majors on our team and different students like that to really have a fully rounded team. And we then will compete against other world-class institutions like Harvard, Yale, Cornell, and the California schools to really build a competitive rover against them. And we ranked pretty well each year. So that's what we've been working on. And then also what we started last year was the combat robotics lead, which are tiny 3D printed robots that are about 8 inches by 8 inches that will then use little 3D printed attachments to compete against each other and really try winning. So we offer, just through my department and projects that I oversee, is I work very closely with the department. It's the first year program with Professor Distes to really have 3 solid robotics projects out of Watson.
Great, and just to follow up, can first year, even second year students get involved with some of these projects, or is it just the seniors?
What's really nice about our projects is these are not capstone projects, meaning they're not senior projects. The combat robotics lead, we work very closely with the EDD department to make sure that we're using skills that they are taught in classes so they can compete in the project. So that project, as well as Micromouse and other smaller scale robotics projects, are really geared towards first year students. And then once they have that year of robotics experience under their belt, we encourage them to apply for a spot on the rover team, which is more competitive. And we do have limited seats available. But once you have that 1 year of experience, we are very happy to take on second year and third year students.
Awesome.
I started when I was a freshman. So,
any other projects any of you students would like to share? I see some good questions are coming in too.
I can talk about what I'm doing. So
ahead,
right now, I am a freshman in the EDD program that Kun was talking about earlier. And what we're doing right now, even through all of this, we're still doing it, is the concept design project. So what I'm doing is, mine's a little different than a lot of the other ones. Mine is my team and I are creating a system to take the wasted energy in like kitchen appliances and turn it into electrical energy to use to like charge a phone. Well, you're choosing to charge a phone, but it's like a small device, and you learn a lot about like project requirements and stuff that goes on in industry. And basically, it's just like a tiny, like a 1 semester version of the senior project, which is the entire year. And it's been, you get experience like working in a team. You have to each week there's a different person who's the project lead, so you get leadership experience and you get so much experience right out of the gate, and it's honestly super fun, and I'll be working on that this weekend.
Great, and then we have some students out there that are asking, I want to get into internships in a second, but if a couple of you can share maybe your best course, your favorite course, and maybe also the most challenging course you've taken so far. And I know this is different across majors, so go ahead, who wants to take this one away?
I can start. So my favorite class I took my sophomore year, first semester. It's called Human Factors Engineering, and essentially it was all about how like humans and like that effect plays into like a system. So it took into account like human error, human emotions, all of that stuff, and how that weaves in. And our like end of semester project was taking any system on campus, and we chose the bus system, the OCCT bus system, and making improvements to make it better. So we designed, like my team designed a visual map, as well as reorganized the website, and had like, we got to contact like the heads of the bus system. We did interviews, took surveys. So it was kind of all around, all encompassing project on like a really interesting topic, because I feel like a lot of times like you don't connect like humans and machines. So
I can answer the other side of that. What was the hardest class you had? For me, it was definitely differential equations in the math department. It's well known by probably pretty much everyone who's taken it that it's like it's not the easiest class, let's put it that way. In my class, the homework was optional, but just the tests are very hard and the questions are long, so you just gotta keep up with your work and kind of stay on top of things to do well.
Going off of that, I was one of the weird people who actually liked ordinary differential equations. I really enjoyed the class, but my hardest class was kind of a step beyond that. It was engineering analysis, and that takes ordinary differential equations and puts it on steroids, basically, and that was definitely very hard.
Awesome, and I know some of you highlighted some of the internships you've done. Anybody want to share an internship story and maybe the internships for the seniors that are turning into a job opportunity? Go ahead, Amelia. I saw your hand go up.
Yeah, so something that I'm involved in is a little different than some people's internships. Some people's internships focus very much on the industrial side, working in a corporate setting. For me, I did that for a little while and I really didn't like it. So I've actually been drawn more into the academic side of things. I work in a faculty research lab now and I absolutely love it. I saw some questions earlier in the chat about getting involved in faculty research. Definitely do it. It's a really, really great opportunity while you're in undergrad. So what I'd recommend is to go on our website and to look at whatever department you're interested in. All of the faculty will be listed and all of their research areas will be listed as well. Really, really great. See if any of that interests you, because getting involved in research is awesome.
Daniel, I see that you wanted to answer a question live. We'll come back to you, Jess, in a second, but just about post-Bing, what happens after Binghamton and job placement?
I was going to throw that back out to the seniors. I felt like that would be a good discussion question. I know, Jess, if you want to talk a little bit about that.
Yeah, I can talk a little bit about that. I have had 3 internships. 2 of them were with BD Medical, and 1 of them was with Regeneron Pharmaceuticals. Joel and I were in the same company, just different locations. He was down near New York City. I was up in the Rensselaer location. Both of those were fabulous companies. A lot of internships do turn into full-time positions. In my case, I decided that while I love the company, I really want to move out to Boston, and the jobs that I had interned for just weren't simply out in that location. I have a lot of interviews lined up right now, fewer than normal spring semesters though, just because a lot of people have started doing hiring freezes. So this is not a normal spring. Normally, a lot of people are doing, I was doing interviews back in the fall, I'm doing them now. Most people are getting all their job offers wrapped up about a month probably before graduation.
Awesome. So I do want to touch on some of these questions. We have about a little over 5 minutes left. I want to throw out to the group, what is that typical school day like for a first-year engineering student? I know, Professor Kuhn, you talked a little bit about what the classwork is like. So you can certainly chime in, but students, I'll let you take this away first. If you want to talk about that first year, and I'll expand upon that. What's that second year look like, and how's that transition?
I can literally talk about what my schedule is right now. It is a first year one. So once a week we have EDD 104, which is Engineering Communications 2, which is the spring semester one. And that's where you're going to get your writing credit, so you don't need to take any like Harper writing classes. You don't need that. It's great. And then that's on one of the days a week. Another day, one of the days a week, it's different depending on what section you get put into. Mine are on Mondays, and my EDD 112 lab are on Wednesdays. And that's like you have a lab and you do stuff like Simio, MATLAB. In the fall semester, you do stuff like, I'm forgetting, you do CADing, that's the word, and stuff like that. And then depending on how much calculus you did in high school, you'll be taking calculus classes and different math classes. I'm in Calc 2 right now. That's fun. And then you'll also, depending on what credits you come in with into Binghamton, you'll be taking Physics 131 right now, which is the calc-based physics that they offer here. And then usually next semester, students take Physics 132, which is the second half. And then in the fall semester of your freshman year, you'd be taking Chem 111, which is the intro chem for the engineering students. And then your electives, of course.
Anybody want to talk about maybe the later years, sophomore year, even beyond, just what that typical day in the life looks like? I know you have a lot of different interest students. You could also share the stuff you're doing outside of engineering, how that either helps or blends perfectly in.
I can jump in. When you get up to higher level years, basically, you spend a lot more time working with groups on projects than necessarily you do the first year. So the first year really is your most time intensive year for in-class like hours. So you're in seat the most amount of hours. When you get up to your sophomore or junior, and especially your senior year, the time that you're required to have be actually sitting in a class go way down, but the amount of time you're required to be working with a group towards your capstone project or your different project, whether you're on a larger scale project, like a lot of the SAE projects or one of our projects, you work a lot more with a group and spend a lot more time just working with a group, hashing out a plan where you have less guidance and more freedom.
Also, in terms of things outside of class, I am one of the 2 managers for Watson Advising, and you'll see a lot of Binghamton students, we're not just doing class, we're involved in clubs, we have jobs on campus, we have jobs off campus, there's all these other things to be doing. I know in the Watson office, we average about 5 hours a week in the office, but a lot of us are hanging out there constantly throughout the day. We go there in between classes, we go there for our lunch. We just like to hang out there. Everyone's there, everyone's doing our homework. It's a great place to just kind of go and in between classes and hang out.
To add to that, there's a lot of activities you can do outside of like engineering. So I'm part of Finance Society. Like I've gotten the opportunity to learn a little bit about the fundamentals of finance and ways I can kind of connect my engineering interest to the financial world and like algorithmic trading and different commodity trading and like different fields like that. Also, I've just gotten the chance to develop like a network outside of engineering and kind of see how I can kind of pull that and leverage that as time goes on.
You know, activities outside of class are really important, and I always encourage students to pursue those opportunities because, as an example, I'm a part of the SACE, which is the Society of Asian Scientists and Engineers. And within that organization, we throw a lot of different events that are geared towards things that you might not get within a classroom setting per se. So we have professional luncheon events, we have events for professional development, where we critique resumes, LinkedIn profiles, and our overall goal is to help students network and engage with the professional world as much as we can. And on top of that, we also have a lot of different cultural events that we throw throughout the year. And extracurricular activities are essential to the overall college experience. So I definitely encourage you to take part in that as much as you can.
I just saw a question come in. I think it's on a lot of students' minds, at least it was on mine way back when I was looking at schools. But do you as engineering students feel separated from other majors, and do you have friends outside of just engineering?
I can answer this. I mean, for sure, definitely. So what the great thing about college is you're not just going to classes, like what everyone's been saying about taking part in extracurriculars. You can join clubs that are social clubs, like the knitting club or like the karate club, things like that. But then you also have to think about like where you're living. So some students choose to be part of learning communities, and that will surround you with a lot of like engineers and students like that. But the majority of student housing is mixed between years and majors. And so my freshman year, I didn't live in a learning community. Well, I never did. And so like I had friends who were in like chemistry or in the business school, and like that's how I made like a lot of my core friends as well. So like it's not just, school is not just classes anymore.
And building on that, definitely where you live impacts a lot of the people you meet. Like my first year, I lived in Dickinson, as I will probably for hopefully all 4 years. You meet a lot of people from different backgrounds. Like some of my closest friends are history majors, economics majors, stuff like that. And having that background and that difference of majors makes hanging out more fun, because you do see the same people a lot when you're working on projects. So it's nice to have a break and have a different set of friends to really hang out with.
Awesome. So this is that moment where we're getting close to the end. We're going to have to wrap up. I know we still have some questions we're answering. I actually just pasted, if all of you as attendees can go down at the bottom in your chat box there, I pasted a link for a Zoom chat hour that we're hosting from now in the next 2 hours, where you can actually talk with some of our students. We're here on the panel, ask those questions face to face, chat them in. We'll have breakout rooms. So it's an opportunity really for you to engage with our current engineering students. You have a more in-depth perspective, especially if you had a question that you didn't get answered right away. So I'll be shutting this part down in maybe a couple more minutes. I'm gonna paste the link again just so you have it. That's the Zoom link here that you can just join our next meeting, which is it's just a chat hour session where you can chime in, ask those questions. Now, any last minute words of advice from our current students? I surely have one thing I want to add, but go ahead, take it away, anybody.
I can just jump in. So one thing that we have to stress is engineering is difficult. There's no way really around saying that. We all put in kind of insane hours some days studying for exams, and you don't always do well. You kind of live and you learn, and you will have friends that are not in necessarily easier majors, but are in majors that are less math heavy, less science heavy. And you have to just take a step back every once in a while and realize that you're both going to college, you may have very different experiences, and you may have to put in more work to the degree that you're passionate about and interested in. And in the end, it will be worth it.
Good, I see you're getting ready to say something. All right, good, because I think I'm reading your mind a little bit here. And look, this is a tough time right now when a tough time and a fun time where you're trying to pick out where you're going to spend the next 4 years. So I trust as you as aspiring engineers are going to do this in a very thoughtful way, but ultimately you're going to try to find the school that frankly offers you what you're looking for. But I assume many of our peer engineering schools offer very similar things. But diving a bit deeper, you're going to look for that school that doesn't just offer you what you're looking for, but gives you an opportunity to do the best you can and to feel the most comfortable, at least the most comfortable that you can step outside your comfort zone a little bit and dig a little deeper. And that's where that collaborative spirit at Binghamton really starts to shine, that you're all in it together. I will encourage you to seek that best value in that engineering degree, right? The school that is going to allow you to really challenge yourself, but also in process, when you look at what our students are doing here today, you see how they're all providing opportunities to even make Binghamton even better when they graduate. That level of student autonomy is something we really take pride in, and I would encourage you to think a lot about that and where you see your paths going. So I'm glad you all made it in today. Congratulations again on your acceptance. Join us over in that chat hour. I'll be joining in the second half of that, the next 2 hour part. I'm going to host the computer science session now, but I'll be in there a little later around 3:45. So awesome work getting in. Keep up the great work. Good luck, everybody. And thank you, current students, for chiming in.